TypeScript monitoring for full-stack developers. Introduction. TypeScript monitoring means tracking errors, performance, logs, metrics, traces, user experience, and API behavior in TypeScript-based applications. Full-stack developers use TypeScript monitoring for React applications, Angular applications, Vue applications, Next.js applications, Node.js APIs, Express Nest.js backends, frontend error tracking, API performance monitoring, distributed tracing, production debugging, user experience monitoring, full-stack observability. A common learning topic is, how can full-stack developers monitor TypeScript applications in production? This guide explains TypeScript monitoring basics, front-end monitoring, back-end Node.js monitoring, logs, metrics, traces, error tracking, source maps, OpenTelemetry, Sentry-style monitoring, React Angular monitoring, Spring Boot integration, dashboards, alerts, best practices, interview questions. TypeScript is a strongly typed programming language that builds on JavaScript and adds better tooling at scale. Monitoring TypeScript apps usually means monitoring the JavaScript runtime output, plus using source maps and structured telemetry to understand the original TypeScript source. Simple definition. TypeScript monitoring means watching a TypeScript application in production, so you know when something breaks, slows down, or behaves incorrectly. Simple flow. User opens frontend. TypeScript app runs in browser. App calls backend API. Backend processes request. Monitoring collects errors, logs, metrics, and traces. Full stack example. React TypeScript frontend. Node.js TypeScript API. Spring Boot API. Database. Monitoring dashboard. Why TypeScript monitoring matters. Without monitoring, users report bugs before developers know. Front-end crashes are invisible. API errors are hard to trace. Slow pages go unnoticed. Production debugging is painful. Logs may not connect front-end and back-end. /TypeScript stack traces may point to bundled JavaScript. With monitoring. Check. Errors are captured automatically. Check. Performance is visible. Check. API failures are easier to debug. Check. Front-end and back-end events can be connected. Check. Alerts notify teams early. Check. Source maps make stack traces readable. Check. Production behavior becomes measurable. Monitoring versus logging versus observability. Concept meaning. Logging records events messages. Metrics numeric measurements over time. Tracing tracks request flow across services. Monitoring watches system health. Observability. Ability to understand system behavior from telemetry. Simple idea. Logs tell what happened. Metrics tell how much, how often. Traces tell where time was spent. Monitoring tells if the system is healthy. OpenTelemetry is an open-source observability framework that provides APIs, SDKs, tools, and collectors for telemetry, such as metrics, logs, and traces. TypeScript monitoring architecture. Browser TypeScript app. Error tracking SDK. Performance monitoring. API calls with correlation ID. Backend API monitoring. Logs plus metrics plus traces. Dashboard plus alerts. Full stack architecture. React, Angular, Vue TypeScript. API gateway. Spring Boot Node.js API. PostgreSQL, MongoDB, Redis. OpenTelemetry collector. Grafana, Datadog, Sentry, New Relic. OpenTelemetry JavaScript supports telemetry data generation and collection for Node.js and browser applications, including metrics, logs, and traces. Core monitoring signals. The main signals are check errors, check logs, check metrics, check traces, check user actions, check page performance, check API latency, check network failures, check memory usage, check deployment version. Common question. What should I monitor first? Begin with errors, API failures, page load time, backend latency, user impacting failures. Step 1. Monitor front-end errors. Front-end errors include sometimes exceptions, failed API calls, component crashes, undefined, null errors, rendering errors, browser compatibility issues, unhandled promise rejections. Example error. Const username equals user profile name if user is null. Type error. Cannot read properties of null. Monitoring should capture error message, stack trace, browser, URL, user session ID if safe. App version, timestamp. Step 2. Use error boundaries in React. React error boundary example. Import React from React. Type props equals children, React node. Type state equals has error boolean. Export class app error boundary extends React component props state. State equals has error false. Static get derived state from error state. Return has error true. Component did catch error info React error info. Console.error React error info. Render if this state.has error return something went wrong. H1 return this props children. Use app error boundary. App error boundary. Important. Error boundary improves user experience. Monitoring tool captures the technical error. Step 3. Capture global browser errors. Window.addEventListener error. Console.error. Global error. Message event.message. Filename event.filename. Line event.lineno. Column event.colno. Window.addEventListener. Unhandled rejection. Console.error. Unhandled promise rejection. Event reason. Use this for unexpected runtime errors, missed promise catches, production debugging, fallback monitoring. Better production approach. Use a monitoring SDK and send errors to a monitoring backend. Step 4. Monitor API failures. API failures are common in full-stack apps. Examples. Cost 400 validation error. Cost 401 unauthorized. Cost 403 forbidden. Cost 404 not found. Cost 500 server error. Cost timeout. Cost course failure. Central API wrapper. Type API error equals status number, message string, URL string. Export async function API fetch t. URL string, options request init equals to c. Const start time is performance.now. Try. Const response is await fetch. URL options. Const duration ms is performance.now. Console.info. API request completed. URL status response status duration ms. If not response.ok. Const error API error equals status response status message API request failed. Console.error API error error throw error. Return await response.json as t. Catch error. Console.error. Network API failure. URL error. Throw error is step 5. Monitor page performance. Front-end performance metrics. Check page load time. Check time to first byte. Check first contentful paint. Check largest contentful paint. Check route transition time. Check API response time. Check JavaScript bundle size. Check interaction delay. Simple measurement. Const start equals performance.now. Await load dashboard data. Const duration mess equals performance.now minus start. Console.info. Dashboard loaded. Duration ms. Node.js also provides performance measurement APIs through perf hooks, including Web Performance API compatible features and node-specific measurements. Step 6. Monitor route changes. For single-page apps, route changes matter. Function track page view, path, string, console info, page view, path, timestamp, new date, .to ISO string. React router idea. Import use effect from React. Import use location from React router DOM. Export function route monitor. Const location equals use location. Use effect. Track page view. Location path name. Return null. End. Use for. Check page usage. Check route level performance. Check User journey debugging. Check. Navigation errors. Step 7. Monitor Node.js TypeScript APIs. Node.js TypeScript backend monitoring includes request logs, check, API latency, error rate, memory usage, CPU usage, event loop delay, database query time, external API latency, unhandled exceptions, process restarts. Example express middleware. Import type, request, response, next function, from, express. Export function, request logger, request res, response, next function. Const start equals date.now. Res on, finish. Const duration mess equals date now minus start. Console.info. HTTP request. Method.rec method. Path, rec path. Status code. Res status code. Duration ms. Next, 8. Step 8. Structured logging. Bad log. Console log. Error happened. Better log. Console.error. Order creation failed. Order ID, user ID, error code, payment failed. Correlation ID. Structured logs are easier to search. Good log fields. Click timestamp. Click level. Click message. Click service name. Click environment. Click correlation ID. Click user ID if safe. Click request path. Click status code. Click duration. Avoid logging. Next, passwords, access tokens, refresh tokens, full credit card data, private personal data, session cookies. Step 9. Correlation ID. Correlation ID connects frontend and backend logs. Flow. Frontend creates correlation ID, sends it in API header. Backend logs same ID. Trace is easier to debug. Frontend. Function, create correlation ID, string. Return, crypto, random UUID. Export async function, API fetch t, URL string, promise t. Const correlation ID is create correlation ID. Const response equals await fetch, URL, headers, x correlation ID, return response.json as promise t. Backend express. App.use rec res next. Const correlation ID is rec.header x correlation ID. Crypto.random UUID. Res set header x correlation ID. Console.info request started. Correlation ID path rec path. Next, A. Step 10. Spring Boot correlation ID for TypeScript frontend plus Spring Boot backend. TypeScript frontend. D. X correlation ID. Spring Boot API. Logs with same correlation ID. Spring Boot filter. Component. Public class correlation ID filter. Extends once per request filter. Private static final string header equals X correlation ID. Override. Protected void do filter internal. HTTP servlet request. HTTP servlet response. Filter chain. Throws servlet exception. IO exception. String correlation ID equals request.getHeader, open parenthesis, header, close parenthesis, semicolon. If correlation ID equals null or correlation ID is blank, correlation ID equals UUID random UUID to string. MDC.put correlation ID, response.setHeader, header, correlation ID. Try, filter chain do filter, request response. Finally, MDC.remove correlation ID. This helps connect. Check, frontend error, backend log, database issue, user request. Step 11. Source maps. TypeScript is compiled and bundled into JavaScript. Problem. Production error points to bundle.js, line 1, column 120938. Solution. Upload source maps to monitoring tool. Source maps help monitoring tools map production JavaScript stack traces back to original TypeScript files. Sentry's JavaScript docs include source map guides, including TypeScript source map upload workflows. Example, tsconfig.json. Compiler options, source map, true. Important. Upload source maps securely. Do not expose source maps publicly unless your team accepts that risk. Step 12. Monitor React TypeScript app. React monitoring should track component errors, failed API calls, route transitions, slow pages, auth failures, form submission failures, front-end performance, user impacting errors. Example structure: SRC, monitoring, error handler.ts, performance.ts, and logger.ts. Services: API.ts, app.tsx, error logger. Export function, log frontend error, error unknown, context, record of string unknown, equals 0. Console error, frontend error, this error, context, timestamp, new date.toso string. Step 13. Monitor Angular TypeScript app. Angular monitoring can use global error handler, HTTP interceptor, route events, API latency tracking, global error handler. Import error handler injectable from @Angular core. Injectable export class global error handler implements error handler. Handle error, error unknown, void. Console error, Angular global error, error, timestamp, new date.toISOSing. HTTP interceptor idea. Export const monitoring interceptor. HTTP interceptor fn equals rec next. Const start equals performance.now. Return next rec.pipe. Tap next. Console info. HTTP success. URL rec.url. Duration ns. Performance.now minus start. Error, error. Console error, HTTP error, URL rec.url, status error.status, duration ms performance.now minus start. Anywho. Step 14. Monitor Vue TypeScript app. Vue monitoring can track global errors, route changes, API failures, component level failures, Pinia store errors. Vue global error handler. Import type app from Vue. Export function, setup Vue monitoring, app.config error handler equals error instance info, console.error, Vue global error, error info component instance type. Use in main ts. Const app equals create app. Setup Vue monitoring, app.mount, #app. Step 15. Monitor Next.js TypeScript app. Next.js monitoring should track client errors, server-side errors, API route errors, page render failures, slow server responses, route performance, build, deployment version. API route example. Export async function. Get. Const start equals date now. Try. Const data is await. Load data. Console.info. API route success. Duration ms, date.now, minus start. Return response.json data. Catch error. Console error, API route failed. Error, duration ms, date.now minus start. Return response.json. Message internal server error. Status 500. OpenTelemetry helps collect traces, metrics, logs, service metadata, distributed request flows. OpenTelemetry JavaScript documentation includes getting started guides for Node.js, where you can instrument traces and metrics. Typical OpenTelemetry architecture. TypeScript app, OpenTelemetry SDK, OpenTelemetry collector, backend observability tool. Use it when you have multiple services. Frontend calls backend. Backend calls another service. You need distributed tracing. You want vendor-neutral telemetry. Step 17. Distributed tracing. Distributed tracing tracks one request across services. Example: React TypeScript frontend, Node.js TypeScript API, Spring Boot order service, PostgreSQL. Trace can show frontend click 20 milliseconds, API gateway 40 milliseconds, order service 150 milliseconds, database query 600 milliseconds. This answers where is the request slow. Step 18. Metrics for TypeScript apps. Front-end metrics. Awk, page load time, API failure count, route load time, JS error count, form failure count, user action count. Backend Node.js metrics. Check request count. Check request duration. Error rate. Check CPU usage. Memory usage. Check event loop delay. Check database query duration. Example metric event. Type metric event equals name string, value number, tags, record, string, string. Function record metric event. Console.info metric. Record metric. Name API request duration. Value 245. Tags, route, API orders, method, get. Step 19, alerts. Monitoring without alerts is incomplete. Create alerts for. Check. High frontend error rate. Backend 5xx spike. API latency above threshold. Login failure spike. Checkout failures. Memory usage high. Service unavailable. Database connection failures. Example alert. If API 5xx error rate to 5% for 5 minutes, notify engineering team. Better alert. Alert on user impact, not every tiny warning. Step 20. Dashboard design. A good TypeScript monitoring dashboard shows check. Front-end error rate. Top browser errors. Slowest routes. API latency. Backend error rate. Request throughput. Failed logins. Deployment version. Database latency. Active incidents. Dashboard sections. Front-end health, back-end health, API performance, user experience errors, deployments. Step 21. Real-world case study project. Full-stack order dashboard. Architecture. React TypeScript front-end. Node.js TypeScript API. Spring Boot payment service. PostgreSQL. Monitoring dashboard. Monitoring requirements. Capture front-end crashes. Capture failed API calls. Track route changes. Track order creation errors. Track checkout latency. Trace request across services. Alert on payment failure spike. Map stack traces to TypeScript files. Step 22. Monitoring folder structure. Source. Monitoring. Logger.ts. Metrics.ts. Tracing.ts. Error boundary.tsx. API monitoring.ts. Services. API.ts. Components.pages. Backend TypeScript. SRC. Car. Monitoring. Logger.ts. Request-logger.ts. Metrics.ts. And tracing.ts. Routes, services, and server.ts. Step 23. Monitoring login flow. Login flow. User enters email password. Frontend sends post API off login. Backend validates credentials. JWT returned. Frontend updates off state. Monitor. Check. Login success count. Check. Login failure count. Check. Login API latency. Check. 401 rate. Check. Frontend validation errors. Check. Unexpected auth errors. Do not log. Next. Password. Next. Access token. Next. Refresh token. Safe. Log. Console info. Login attempt completed. Status failed. Reason. Invalid credentials. Correlation ID. Step 24. Monitoring API layer. API wrapper should capture URL path, method, status, duration, correlation ID, retry count, error message. Example. Export async function, monitored fetch, t, URL string, options request init equals, comma, promise t. Const correlation ID equals crypto.randomuid. Const start equals performance.now. Try, const response equals await fetch URL, dot, options, headers, dot, options dot headers, x correlation ID, Const duration ms equals performance.now minus start. Console.info. API request. URL, method options method, get, status response status, duration ms, correlation ID. If not response.ok, throw new error. API failed with status/response status, end dot. Return response.json as promise t. Catch error. Console.error. API request failed. URL, correlation ID, error. Throw error. R. Step 25. Monitoring Node.js memory. Node.js memory example. Set interval. Const memory equals process.memory usage. Console.info. Node memory usage. RSS memory.rss. Heap total memory.heap total. Heap used memory.heap used. External memory.external. Monitor memory when. Capital. API slows down. Memory leak suspected. Process restarts. Container is OOM killed. Heap usage keeps increasing. Node.js diagnostic reports provide JSON-formatted diagnostic summaries intended for development, test, and production use. Step 26. Monitoring event loop delay. Event loop delay can indicate Node.js is blocked. Example. Import. Monitor event loop delay from node perf hooks. Const histogram equals monitor event loop delay, resolution 20. Histogram.enable. Set interval. Info. Event loop delay. Mean ms, histogram, mean, divided by 1 million. Max ms, histogram.max, divided by 1 million. Histogram.reset. 60,000. Use this to detect CPU heavy code, blocking synchronous operations, slow JSON processing, bad loops, large file processing. Step 27. Production deployment monitoring. For every deployment, track, version number, commit SHA, build ID, environment, release time, error rate before after deploy. Frontend build variable. Export. Const app version equals import meta.end vite app version. Log. Console info. App started. App version. Environment import meta.env.mode. Why? When errors spike, you can identify which release caused it. Step 28. Common beginner mistakes. 1. Only using console.log. Bad. Console.log error. Better. Use structured logs and a monitoring platform. 2. No source maps. Problem. Production stack trace points to minified JavaScript. Better. Upload source maps so errors map back to TypeScript files. 3. Logging sensitive data. Bad. Console.log access token. Console.log password. Better. Never log passwords, tokens, cookies, or private data. 4. No correlation ID. Without correlation ID, front-end error and back-end log are hard to connect. Better. Send X correlation ID with API requests. 5. Monitoring only backend. Bad. Only monitor Spring Boot or Node.js API. Better. Monitor front-end and backend. Many user-impacting problems happen in the browser. 6. Too many alerts. Bad. Alert on every warning. Better. Alert on user impact and critical system behavior. Best practices. Monitor front-end errors. Monitor API failures. Use source maps. Use structured logs. Include correlation IDs. Track API latency. Track route page performance. Track backend request duration. Monitor Node.js memory and event loop delay. Avoid logging sensitive data. Connect frontend and backend traces. Dashboards, check. Create meaningful alerts. Track deployment version. Test monitoring in staging. Review top errors weekly. Fix noisy logs and useless alerts. TypeScript monitoring. Interview questions 1. What is TypeScript monitoring? TypeScript monitoring means tracking errors, performance, logs, metrics, and traces in TypeScript-based front-end or back-end applications. 2. Why are source maps important? Source maps map production JavaScript errors back to original TypeScript source files, making debugging easier. 3. What should be monitored in a React TypeScript app? Monitor runtime errors, failed API calls, route performance, page load time, user-impacting errors, and deployment version. 4. What should be monitored in a Node.js TypeScript API? Monitor request count, latency, error rate, memory usage, CPU, event loop delay, database latency, and unhandled exceptions. 5. What is a correlation ID? A correlation ID is a unique ID passed across front-end and back-end requests to connect logs and traces for the same user request. 6. What is distributed tracing? Distributed tracing tracks one request across multiple services to show where time is spent and where errors happen. 7. What is OpenTelemetry? OpenTelemetry is an open-source observability framework used to generate, collect, and export telemetry data, such as metrics, logs, and traces. 8. What is the difference between logs, metrics, and traces? Logs are event records. Metrics are numeric measurements. Traces show request flow across services. 9. What should you avoid logging? Avoid logging passwords, tokens, cookies, private user data, secrets, and sensitive headers. 10. Why monitor front-end apps? Because many production failures happen in the browser, including rendering errors, API failures, JavaScript exceptions, and slow user interactions. TypeScript monitoring roadmap, beginner level. Learn. Check front-end errors, check console logs, API failure handling, check loading error states, check source maps. Build. Monitored React TypeScript API client, intermediate level. Learn. Talk. Structured logging, correlation ID, metrics, route monitoring, Node.js request logging, dashboard basics. Build. React TypeScript plus Node.js monitoring demo, advanced level. Learn. Click OpenTelemetry, distributed tracing, alerting, source map upload, release tracking, memory event loop monitoring, full stack observability. Build. Production-ready full stack observability setup, 30-day learning plan, week 1, front-end monitoring. Learn. Call error boundaries, global errors, unhandled promises, API error handling, loading error states. Practice. Add monitoring to React TypeScript app. Week 2, backend monitoring. Learn. Key request logs, structured logging, latency tracking, error middleware, memory usage, event loop delay. Practice. Add monitoring to Node.js TypeScript API. Week 3, full stack correlation. Learn. Correlation ID, front-end to back-end headers, Spring Boot MDC, API wrapper monitoring, dashboard design. Practice. Connect front-end and back-end logs using X correlation ID. Week 4, observability. Learn. Check OpenTelemetry, traces, metrics, source maps, release tracking, alerts. Practice. Build full-stack monitoring dashboard and alert rules. Real-world project, TypeScript monitoring dashboard. Architecture. React TypeScript frontend, Node.js TypeScript API, Spring Boot payment service, PostgreSQL, OpenTelemetry monitoring platform. Features. Check front-end error tracking, check API wrapper monitoring, check correlation IDs, check backend request logging, check source map support, check route performance tracking, check Node.js memory monitoring, check event loop delay monitoring, check dashboard metrics, alert examples. Final summary. TypeScript monitoring is essential for full-stack developers building modern front-end and back-end applications. Important concepts include CAI, front-end error tracking, API failure monitoring, source maps, structured logs, metrics, traces, correlation IDs, OpenTelemetry, React Angular View monitoring, Node.js monitoring, Spring Boot integration, dashboards, alerts, release tracking. Full stack developers should remember: monitor the browser, the API, and the request path between them. Key idea: TypeScript monitoring helps full stack developers detect production errors, understand performance problems, connect front-end and back-end behavior, and fix issues faster.